One of the highest points is 26 inches from the firewall, so about here, and it's about 60 inches tall, so that it would show up a little bit on the bottom of the corner. This could be a potential problem when it comes to visuals. I can either move this back and move the entire simulator back, or I can install a separate projector. There are pros and cons to both of them, mainly cost for the projector. So I think the better solution would be to move the simulator back a little bit. So the very top of the flight simulator is at 55 inches from the cabin. So you'll see right here, I set my measuring tape to 52 inches, and I know that this part of the tape measure is roughly 3 inches. So I can use that as a 55-inch pole, and we can see that it does not interfere with the projector. So that means we can have our simulator, at least theoretically. We have to account for the base though. Ready? 3 inches for the wheels and 2 inches for the base, which cuts just slightly into our projection. Here's without the base, here is with the base. So it just pops up ever so slightly. If this is a problem, in the future I could get a 180-degree curved surface with some short throw projectors that have a much shorter focal point or distance from the lens to the wall, and then that'll make it so that there's less distance and I can have the projector with a basically wider angle so that it just displays right down onto the wall instead of having it, I think, 15 feet away. Currently the wall is about 17 feet away from the projector, which makes this a little hard, but it's a good challenge.
Okay, right now I'm using a tool called elif.net. It's where you can get an image and give it a known dimension and then find other dimensions from it. It looks like we want it to be at least 40 inches wide, so I'm gonna make sure it can fit through 48 inches. I don't think any more will be needed than that. In fact, right here, it's only showing that we need 42. But I want a few inches of slack to fit through the door. So right here, I have certain dimensions, and I can go from the floor of the actual Cessna 172 to the roof to see what this dimension is, and see that this dimension is 51.05. And then I'll add 8 inches right here for the base, and then that's how high the simulator is in total. I'll find where this is from the firewall by dragging this over to the firewall. I can even press Control to snap it horizontally. This shows me 60 inches. So right here in the middle of this door, 60 inches from the firewall, the height in total is 59.05. I can then go over to the setup and measure that just to be sure.
I've been getting a lot of questions about how I'm going to build the simulator. It's a lot easier to make things on the computer than it is in person. On the computer, you just drag a line. In person, you get a piece of wood, kind of bend it. You have to bend it perfectly, and sometimes wood doesn't really like to. Sometimes it just doesn't like to do what you tell it. So that's going to be a really tricky problem. To make sure I'm using the right material, the right form, the right methods, just to make sure that I don't make something I can't build. What I'm going to try to do here is try to see if I can replicate some profiles, just to make sure that I can in fact do this, because if I can't, that would be hilarious for you, sad for me. So I have a measuring tape. I do know how to use this for the record. We're going to make the tightest curve a radius of 24. So it'd be something like this. It goes and kind of sweeps out. The Cessna 172 bends more in some areas and is less curved in others. So we'll have to keep that in mind. My initial plan was to use this plywood. Let's see if we can't get away with that actually. Oh wow, this one really doesn't like to move. Then again, after the pandemic, not a lot of people like to move. I don't think I like putting wood under this much stress. It looks like it's going to be pretty tricky. This right here is 5/16 inch plywood. Yowza, what I might try is just leaving it outside for a year, because this is some 5/16 wood I left outside for about a year, and it's perfect. So I might actually look into some bending techniques. This is 3/8 inch, and it's actually bending pretty well. You can kind of hear it cracking, but we're going to ignore that. For curves, it's going to be a little complicated. What I might do is what boat builders kind of do, and instead of trying to bend the wood like this, kind of pressure it into bending like this, I might try kind of shaping wood together, kind of like this, where you get a bunch of thin pieces of wood and you can kind of bend them together. Then after that, you can trim them up here and glue them together. From there, you can sand the rough edges, and it makes a pretty okay curve. The problem is that the Cessna is not a perfect curve, kind of goes and intersects like this, which would be a little problematic. The curves kind of intersect and go from small over to big over here. As for making the curves, I think I'm going to have to do the mitered method, where you have to cut, miter it at an angle, cut, miter it at an angle, and so forth. But I think I can get a pretty okay result from that, and then kind of cut an inside profile. If you think too hard about it, this construction actually is kind of a little bit similar to the actual Cessna 172 construction. They have ribs and skin, kind of. Right now I'm really leaning towards construction grade 3-inch plywood. And if you have any objections to that, let me know in the comment section down below. Right now is a pivot point. Instead of using this model for everything in the simulator as like a workhorse, I'm going to use this model in little tiny sections. I'm going to mirror this and then split the little parts and put those little parts into other places. And this origin plane splits the first section. From here, I can go in and put these in and derive geometry from these and make my ribs. I'm going to start with the first section because it's the least critical. I'm going to make sure that these are linked, so if I change something down the road, it will update right here. What I can do in my 0-1 version 5 shell is go over here to create, press derive, save it first. Of course I need to save it, and derive this object to an existing design. Under section 1, 1-1 complete assembly, I derived it, and it should be shoved into 1-1. With my organization system, 0-0 is the full assembly of the entire simulator. 1-0 is the entire assembly of just the first section. And then, it gets really fancy, 1-1 is just the shell, the build-up and structure, as well as the skin. One thing really quickly is I'm going to go to my 0-1, so my entire shell, and figure out how much floor I need to cut out. And this canvas is the side cabin view. This will just give me a dimension from the origin to the floor. From the origin point right here to this line down here, and we're going to say this is 18.15. Add that to our comments because we want to have 18.15. Post that, and we have this reference dimension shown. I can create an offset plane that is 18.15, and then that is exactly where the floor is. Now what I can do is I can split this body right here, and then I have two parts. We're going to split this body 24 inches from the origin, and that'll let it fit through the door. You might ask me, yo, Bob, why are you designing this little chunk first? And that is so that I can practice my techniques in both CAD and real life before I ever go on to my beautiful second section. From this drawing, I can take a profile right here and a profile right here, and then basically trace these onto wood, cut the wood out, put it into place, and then cover those two profiles. I did a good amount of thinking and discovered 12 inches I think would be the best distance between ribs. Floorboards are traditionally required to be 16 inches across on center. I'm going to choose 12 inches because each of my sections is 2 feet. 2 feet divided by 2 is 1. 1 foot is 12 inches. Gosh, I hate the imperial system. Why am I using imperial, you might ask? Because the Cessna172 is in imperial, and if I ever want to buy screws OEM from the Cessna172, I would have to convert from metric into an imperial counterpart, and things wouldn't really line up. My building materials are sourced in imperial, so if I want to buy 10 feet of lumber doing this design, I know that I need to buy 10 feet instead of, oh yes, about 3,000 millimeters. Yeah. Now we're going to make a mid-plane that is in between the two profiles so that it's right smack dab in the middle. I can project this front face and then use it as geometry. I'm going to make a centered rectangle, and then I'm going to make it a certain amount high and then a certain amount thick, and the thickness will be 0.75 inches. I want this to be constrained vertically to the origin. I can then lift it up until the profile, the little square, hits the profile. I'm going to add a few parameters. One of these parameters is going to be standard plywood, or standard ply. It's going to be 3/4 of an inch for now. I can change this later if I decide to go with a different thickness of wood. Then I can set the width to standard ply. I made the first profile, completed it, and projected it to the second profile. And this time I'm just doing a normal rectangle and setting the type to string thickness. This is another parameter I used, and I'm actually constraining this top line to the dot right here, and then making it the midpoint. I'm doing the same thing, but instead I'm using a 3-point rectangle and making sure that it's perpendicular to my guidelines I made through the center. These guidelines are made at 45 degrees, and that allows there to be 8 guidelines, and I think that's the most intuitive for me. Again, everything is constrained to standard ply or stringer thick. Oh, right here, I kept constraining the line to the other line through midpoint, but it doesn't work that way. You have to constrain a midpoint to a point. I also offset this canvas the sheath ply amount. Sheath ply is another parameter I used. It's 3/8 of an inch, and it's the amount we have to account for when we're making the shell. You'll notice, since I constrained these all to the top layer, we have to reconstrain them to the offset layer. You really want to make sure you constrain things to the origin. Never assume anything. Double check that it's right, because if you zoom in a lot, you can start to reveal the shocking truth. I continued constraining everything to the offsetted edge, And what I did was I added some dots. The dots really help you constrain things to the midpoint, so the point can be constrained to the midpoint. Repeat until you're blue in the face. Sweet! We got all our profiles, and now we can mirror them. I made a vertical mirror line and constrained it to the origin, and now I can mirror all of my little profiles across that line, and I only have to do it once. It's brilliant. Now I'm working on my third profile, and I can project the face, so where the actual model intersects, and I can also project all of these little guidelines I did in the first place. I turned projection link on because if I want to move one of the profiles, I want to have them move down the road too. Before I start making my rectangles, I really want to offset this by the sheath ply distance, so 3/8 of an inch. And then I can make my rectangles and constrain them to the offset line. It's important to do everything to the offset line and not forget it, because the thickness of the plywood does exist. I don't want the middle plane to be fully solid, because I want to put stuff in the first section. So I'm offsetting it -2 stringer height. I can make this less or more as I need to. I extruded the second profile symmetrically and set the whole width to standard ply. I extruded the third profile one direction. No, not the band. I just extruded it left. And I did this standard ply. I didn't do it symmetrically because we want it to go into the center, not from the center. I did the first one to the right, so they both point into the center. I'm making a new component, and this is going to be the floor assembly. I'm going to start a sketch on the bottom, and then offset this little profile 2 inches. I'm going to slice a line through the top, so that it doesn't create the curve in the front. I'm going to extrude this profile. Again, this is standard ply. We're going to need to also, for later, measure up how high the cowling base is from the origin. So it's 2 inches above the origin, and I can use that for later. Just take note of that. And something magical just happened. It actually updated our current model with the cowling height that we just added. So everything is parametric and fixing things down the road, which I think is really cool. I am adding these little fins because I realized that I had everything hovering. Since I did an offset from the edge to the center, it removed material from the bottom surface, which I actually want to keep. I tried sweeping this profile with the model I made before, but I didn't get really clear results. So I'm going to try a different method where I intersect something, draw a little profile, offset it, then extrude.
There are 2 ways that I can make these planes that I'm going to draw the ribs off of, more or less. I can either make a plane at an angle right here, like this, or I can make a midplane between these 2 sides of this support. So just make a midpoint right here, and it would look like this.
Right click and swipe up. That just repeats the last command you did. It's super helpful. Right here I've made 4 planes, and since a plane can extend forever, this makes the 8 profiles right here for the 8 little holes. I guess 7 because there's not one on the bottom. These are directly in the middle. What we're going to do is create a sketch on each plane and then make a stringer out of that, and then we're going to put the stringer out and just flip it. Doesn't make a whole lot of sense right now, but it will, hopefully, in the future. So for the ribs, I have a line right here, and this is the line that the body is going off of. It's actually where they intersect, so I used a project intersect, and this follows the actual geometry, I like using that word, of the Cessna 172 body right here. So it's basically taking a silhouette of it. I can use this and then offset it. And how much am I going to offset it? I'm going to offset it string thick. That's the thickness of the string. You'll notice now that puts it now right over here, and it offsets the line so that it puts what it needs to be where it needs to be. That worked for the first one. We're just basically gonna do that with all of them. I can then take this rib and extrude symmetrically the whole distance, and then the distance is going to be standard ply, and then we're gonna make a new body. And it's looking pretty good. No, it's not. I forgot to use the offset. One of the joys of parametric modeling. Now this accounts for the sheathed plywood. I just finished basically everything for my model. So we have the front structure, the middle structure, and the back structure, and then how they all fit together. I'm really excited about this, you might be able to tell. But something that doesn't really look good is it looks too much like a cage, honestly. These bars, I feel like they're actually too thick. The minimum distance between each other is 3.5 inches. This is a 2x4 in width, so that's this much. I think that's a bit much, but the beauty of parametric modeling is I can go over here and then under change parameters right here, since I set each parameter to sheath ply, standard ply, or string thick, I can come back and change this, and theoretically the entire model should update. So if I change this to, let's say, 3 instead, we can see how much of an impact that makes on the overall view. So let's press OK, and you'll see that that got just a little bit thinner. I can even show you that again if you want to see it. 3 inches right here, and then 3.5. So this entire model just updated. No, don't go to 35. We now know that if the plywood is 35 inches, it doesn't work very well. I meant 3.5. Sorry about that. I really like either 2.5, looking like this, because I feel like this is a lot thinner, or even 3. I want it to be more open. I just clicked one button, changed one number, and they all changed, instead of going back and saying, oh no, 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 3.5, that should be 2.5. Oh, here's another one, and going back and forth. It's super easy, one button to rule them all, and it's super easy to learn too. Legit, I thought it was this crazy thing, and you have equations, and you gotta use like trigonometry and calculus, but no, you just go over to the modify window, change parameters, and you can just click a little add user parameter. For example, we could make something parametric that just is named subcount, and something is as long as how many subscribers we have. It would be hilarious. Right now I have 2218, and then press OK. And you could make something that's as long in inches as how many subscribers you have. I'm not going to try it. Really simple. and then when you're typing anything into the equation, you just type in your parameter name. One thing I didn't really work on today was the base with the wheels. This is going to be more simple. I can use triangles and angles if I want to. This will probably have roughly 12-inch spacing, so as I was using before, I do want to have space for the wheels. The wheels are right here, and I want to make sure that there's enough space between the spacers so that the wheels can roll all nicely. And I need to not only factor in this little point right here for the wheel to turn, but since I'm likely going to have these built like this, more or less, so that it doesn't take up as much height, I really need to make sure that I leave enough space for the wheels to caster. These wheels are 3.5 inches tall, and they need to have a swivel radius of 2.5 inches. I'm going to go over to the floor assembly, and then let's go for it. New sketch, and then we're going to make a bunch of 2x4s. To swivel properly, the wheels need a certain diameter of swivel. My wheel's diameter is 5 inches, so I'm making sure that the wheels can do a full rotation without any interference from the wood. I can go ahead and dimension this from all the sides, and this gives me about 1.5 inches of clearance. I didn't want to model my wheels personally, that would be kind of extra, so I went to the McMaster car component under the insert tab and inserted a wheel that I found that was similar to my specifications, so a 3-inch diameter. I also am making spacers to raise the wheels, or I guess lower them. They're 3 inches by 3 inches, and that'll fit on my mounting plate. I'm making 4 wheels and then making joints to all of them. I don't need to CAD the wheels, but why not? It looks epic. That concludes just about everything that I need to do to design my simulator before I go out with a jigsaw and cut the profiles. I can really see my CAD skills growing, and I hope this project inspires you to make a flight simulator of your own. Just so you know, if this is your first video, there's a whole ton of other CAD videos I've done on the how to make a flight simulator shell, so go check those out. I will see you next week, and for now, I'll see you later. Have a fantabulous day.